ROZI, and I will be explaining about our robotic arm mechanism. Our robotic arm will be used 3 servo motor. The first servo motor will be placed vertically on the base of our robot. The first servo motor will be functioned as to rotate the robotic arm 360 degrees. At this angle of rotation, it will allow our robotic arm to pick up and drop the ping pong ball at any position. With this advantage, it will shorten the time taken for us to pick and drop the ping pong ball from the pick-up point to the drop-up point. The second servo motor will be placed directly on the first servo motor. The second servo motor will be placed horizontally on the first servo motor. The function of the second servo motor is to control our movement of the arm, either going up or going down, for the purpose of picking up and dropping out the ping pong ball. The third servo motor will be placed at the arm of our robotic arm. The function of the third servo motor is used to grip the ping pong ball during the movement of our robotic arm. At the final end of the robotic arm, we will place some type of rubber to enhance the gripping of the ping pong ball during the movement, so that the ping pong ball will not be thrown out during the process of movement. On the platform of our robotic arm, we will be used only a single motor to control the movement of our robot, which is forward and backward. This is because, as I mentioned earlier, the advantages of our first servo motor already cover up the movement of our robot, so we don't need any other motor to control our movement of platform or base, either to move to the right or to the left. We only need one motor that will control our tire to either move forward or backward. At the platform of our robotic arm, we will be used only one single motor, single DC motor, battery supply, and one belt to connect the DC motor with the behind tires, so that the motor will control so that the motor will allow the tire to move either forward or backward, depends on our input on the programming. So that's all about our motion and translation of our robotic arm. Thank you.
Circuit for servo motor. Basically, here we have 2 joystick and also 3 servo motor. So for joystick 1, we will control servo motor 1 and also servo motor 2, while for joystick 2, we will use it to control servo motor 3. So basically, joystick 1 in X-axis, it will control servo motor 1, while in Y-axis, it will control servo motor 2. For joystick 2, in X-axis, it will control servo motor 3, while in Y-axis, nothing happen. So for joystick 1, for the analog pin, we choose to put it at A0 and also A1. For joystick 2, we use the analog pin A2. So for servo motor, we connect it to the digital PWM. For servo motor 1, we connect it in digital PWM3. For servo motor 2, we connect it at number 5, while in servo motor 3, we connect it at number 7.
Hi, I would like presenting the DC motors, DC motor circuit as functionally to move the robot to its destination. Therefore, I will introduce the component we use to make this robot move successfully. First of all, we need batteries, Arduino Uno, DC motors, 2 DC motors, and a motor driver IC. Batteries is used to supply current and voltage to the motors, and Arduino Uno as a microcontroller to control the movement of this robot. Next is the motor. Motor is functionally as move to rotate the tires front and rear. So since there are 2 motors, so one motor cover 2 tires, which mean front 2 at the front and another motor 2 at the rears. So next is motor driver IC. We use L293D IC because it is a typical motor driver which allow the DC motor to drive on any direction. So this IC contains 16 pins which used to control 2 set of 2 DC motors instantaneously in any direction. So it's very easy for us to use 2 DC motor in one motor driver IC. So there are two type of battery. One is 9 volt and another one AAA that use 4 batteries. So we need more batteries because the power supply from the Arduino Uno cannot rotate both motors simultaneously. So we need extra battery in order to both motors work simultaneously, so the robot move efficiently. That's all. Thank you.